Very nice. Good morning. Okay. So I see here about 50 odd participants. If you can hear me, please raise your hand, please. I just want to check whether you are clear. All right, perfect. Good. Yeah, good morning, all of you. Yeah, you can put down the hand. So I can see the names. Some of the names I'll just read out. Jyoti, Mahinder sir, Sunita madam, Raihan bin Hussein, sorry, Hassan, Rohak, Madhavi ma'am, Hakim, Vidya, Hanud. Yeah. I'd like to know how many of you are from Hyderabad. Those who are from Hyderabad, can you please raise your hand? Okay. So there are 15 participants, 15, 16. How many are from total Telangana? Telangana state. Okay. 20. All right. Finally, how many are from other than Telugu states? Not from Telangana, not from Andhra, other states. Are there anybody who are from other than Telangana and Andhra? So I see there are 12 participants raising hand other than Telangana and Andhra. So I'm assuming that you would be comfortable either in English or Hindi. Those who cannot understand Telugu, can you please raise your hand? Those who can't understand Telugu. All right. Okay. About 10 members are there, those who can't understand Telugu. So we'll have our conversation mostly in English. So I may not be that much comfortable in Hindi. I can understand Hindi, but conversing may not be that good enough. So we'll have a common language, English. All right. So yeah, there are about 75 members now in the box here. That's very good. Nice to see enthusiasm early in the morning. So many people are interested to learn a little more. Yeah, another question. How many of you are already teaching for IIT Advanced program? IIT Advanced. Can you raise your hands? Those who are already taking IIT Advanced classes. That's pretty good. Almost like around 10 members are there who are taking advanced classes already. That's very nice. Yeah. Yeah, Narayan sir. So please remove that what you had written on the screen. Yeah, thank you. Yeah. So how many have not taken any junior college classes? Neither IIT JEE mains nor advanced. Not taken even mains classes also so far. Not even mains classes. Okay. So there are about 20 odd people. All right. All right. Perfect. Very good. Very good. So we have some faculty members who are already taking advanced classes. There are some faculty who would like to learn from even mains level as well as advanced. So I'm assuming that there's another program which takes care of only mains. Probably you will be participating in that as well. Okay, right. Okay, then. So we'll start the discussion today. So today, what I wanted to do was I didn't want to specifically cover one particular topic, but just to give you an idea of what is expected from this question, this particular session, I'm trying to give you idea. So what we will do is we'll start with a particular question, because I always believe in that if you want to learn concept, see, learning concept is one thing. Learning concept. If you want to learn, you can read the books. Okay, you can read the book. But if you want to master the concepts, all right, master, then you need to master only through problems. I think this particular through problems. So handwriting is not coming properly. Anyway, so yeah, so problems is very important. Now that you are come for advanced exam, advanced program, so I'm assuming that basic concepts and all everything is known to you. You want to go to the higher level of concepts, maybe you would like to learn some ways of solving difficult questions, tough questions, conceptual level questions, higher level, advanced level questions. Basic understanding is already there. All right. So that's the assumption for this particular program. So I'll take a question. You please try to solve this question and let us see. After that, we'll go on and as to what I'm expecting from this particular program. Okay. So I'll just write the question. Yeah, please take down this question. A person. I think I need to increase the thickness probably. A person of mass 50 kg screen is a little slow, but anyway, we'll get used to it. Sorry. Yeah, a person of mass 50 kg is running on a horizontal surface. With a constant acceleration. With a constant acceleration. Of 2 meters per second square. Starting from rest. Okay. Is going with a constant acceleration starting from rest. And the direction of motion is, let's say, towards east. So I'll ask you a question here. Number one. Direction of friction. So handwriting is becoming a problem. Yeah, I'll give the friction coefficient also. Coefficient of friction is 0.5. Coefficient of friction is 0.5. Determine direction of friction. That's first one. Option A, along the direction of motion. Option B, opposite to direction of motion. So I want you to choose any one of the options, and after that I'll build on the question. Yeah. So I'm just trying to change the software also because handwriting is a little problem on this. Meanwhile, you try this one. Yeah. So tell me, what is the answer? You can type your answer in the comment box. Option A or option B? How many go for option A? There is a chat box there. You can use the chat box to answer it. Okay. Chat is disabled. No, others are able to chat it. You see, sir. Yeah. So I can see almost all the people have answered it. Now we got many of them are going for option A, and some of them have gone for option B also. All right. Okay. Perfect. Okay then. All right. So to answer this question, we'll have to look at one idea. So does force causes acceleration, or acceleration causes force? Okay. Does force cause acceleration or acceleration cause force? If you look at that idea, it is very simple from the Newton's laws of motion, that force is the source of acceleration. Force causes acceleration. All right. So acceleration causes force is an incorrect statement. Force causes acceleration. Then which force causes acceleration? Is it external force causes acceleration, or internal force causes acceleration? Okay. What kind of force causes acceleration? And if you remember, when you draw free body diagram, you are not supposed to show any internal forces on the free body diagram. We'll show only external forces. So external force causes acceleration. Okay. So force causes acceleration, and that too external force. The next question is, what are the external forces here? What are the external forces on the person now? If you draw the free body diagram for the person, what are the external forces? Not the internal forces. I'm not talking about muscular forces. Muscular forces will be internal forces. External forces, if you look at, what are the forces? Obviously, first thing is gravity. Okay. Gravity is vertically downward, mg. But mg is vertical, which cannot produce horizontal acceleration. Vertical force cannot produce horizontal acceleration. So mg is not the reason for this acceleration. And then you have normal reaction. Normal reaction also is a vertical force that also cannot produce horizontal acceleration. Then what causes horizontal acceleration? Let's say horizontal acceleration is right side. There should be an external force horizontally, which causes acceleration. And on the horizontal direction, the only force that is acting on the person is friction. So if friction is causing acceleration, friction cannot be opposite to acceleration. Friction should be in the direction of acceleration. Friction should be in the direction of acceleration. That means the answer is option A. So there is a logical sequence that we need to go in to go with the direction here. All right. First, force causes acceleration. Which force? External force. What are the external forces? Mg and normal reaction and friction. Mg normal reaction are vertical forces. Vertical forces cannot produce horizontal acceleration. Leave them. Only horizontal force that is available on the person, acting on the person, is friction. So friction produces acceleration here. That means friction has to be in the direction of acceleration. Cause and effect cannot be opposite to each other. If friction is right side, acceleration would be right side. So what happens here is, now if you understand what is happening, when you are running, you kick the ground backward. You kick the ground backward. That means on the ground, friction will be backward. Action to reaction, ground will exert a frictional force on you on the forward direction. So the friction on you has to be in the direction of acceleration. Here, friction is causing acceleration. I hope all of you understood that point. If there are any doubts, please raise your hand. If you're okay with it, I'll go for the next question. In that only, second part I'll go to. Those who have the doubt, please raise your hand. Otherwise, we'll go on with the next question. Very good. Friction causes acceleration. Correct. Force causes acceleration. Very good. External forces only we should draw. So there are certain concepts that we need to revise. All these are basic concepts, but you need to go in a sequential order. We should not jump to the conclusion all the times. So first, you go in a sequential order. Conceptually, you need to go to the end of the problem. Okay. So once again, force causes acceleration. Only external forces cause acceleration. And there are three external forces here. Normal reaction, mg, friction. Normal reaction, mg cannot be able to produce horizontal acceleration because they are vertical. So what is the horizontal force? Only friction. So friction should cause acceleration. That is the conclusion we get. And reality also, now you go for the observation level. You kick the ground backward. On the ground, friction is backward. And on the person, it is forward. So with that, we'll go to the next question. Now, in this question only, I'll ask you the second part. Determine, second question. Determine magnitude of friction. So I gave you mass is 50 kg. Okay. And acceleration is 2 meter per second square. And coefficient of friction is 0.5. For simplicity of calculation, you can take acceleration due to gravity is 10 SI units. So this is the data given. We need to find the magnitude of friction. So over here, I'll give the options also. First one, magnitude of friction. (250 Newton). Option A. Option B, 100 Newton. Option C, 0. Option D, data insufficient. Data insufficient. This particular software is not very comfortable in handwriting, but anyway, let me see with the other software as well. Meanwhile, let us complete this question on this software. After that, I'll go to the new software, wherein I think you will be, the handwriting would be a bit more comfortable. I think so. Okay. Yeah. So you can type the answer, those who have got the answer. Okay. Rajesh sir has given the answer. Bhaskar sir has given the answer. Okay. Trived also had given the answer. Okay. So let us look at it. How do we go about? They're asking about the friction, right? Whenever they ask about friction, first step that you need to do is, what is the nature of friction? All right. Nature of friction. First thing you need to see is nature of friction. So nature, generally, there are two types of nature. One is static friction. The other one is kinetic friction. All right. F suffix S, static friction. The other one is kinetic friction. So we need to decide what is the nature of friction first, whether it is static friction or kinetic friction. That's the first important step. Whenever you are solving a question in friction, first we need to identify nature of friction. So yeah, some people have already given the answer. It is static friction. Yes. Static friction. How do you know it, whether it is static friction? How do you decide whether it is static friction or not? If there is a slipping on the foot, if the foot slips on the ground, it is kinetic friction. If the foot is not slipping on the ground, then it is static friction. So foot slipping on the ground, in the sense dragging on the ground. For example, you are doing a moonwalk, for example. You are not doing a normal walk, moonwalk. moonwalk, like Michael Jackson was doing it, right? So where you drag the foot, there is a rubbing of the foot on the ground. When you rub the foot on the ground, then it is kinetic friction. But whenever you don't have a rubbing on the ground, then it is kinetic friction, static friction. Okay. So somebody was asking, Zafar was it? Yeah. No relative motion and all, yes. Compared to that, the best way to understand the nature of friction is that whenever there is a rubbing on the ground, this is rubbing. I think you can see my hand. This is rubbing. If this kind of rubbing is happening, a skidding, sliding is happening between the foot and the ground, then it is kinetic friction. If there is no rubbing or sliding or skidding on the ground, then it is static friction. So usually when you go for a normal walk or normal running, the sliding on the ground is neglected. There will be a microscopic sliding in reality, but for all practical purposes, that sliding on the ground can be neglected, especially when the ground is rigid. If the ground is muddy or sandy, then you will have more rubbing, more skidding. But if the road is assumed to be rigid, which is usually the case in our examination point of view, so you can assume that the rubbing of the ground on the surface or rubbing of the foot on the surface can be neglected. Under that scenario, you can take it to be a static friction. So usually for the examination point of view, unless mentioned otherwise, the surface is assumed to be rigid and the feet are assumed to be not sliding on the ground for a usual walk. So it has to be static friction. The moment you decide static friction, then how do you find static friction? Static friction, there is no formula. Static friction, you cannot write mu s into n. That is wrong. Okay, static friction, we don't have a direct relation like this. This is Coulomb's law of friction, we call it as. Coulomb's law of friction is not equality. All right, Coulomb's law of friction is inequality. So this is a wrong statement. What you got to write is static friction has to be less than or equal to mu s into n. So mu s is 0.5, n is the gravitational weight you take, mg equal to normal reaction. So you see that it will be 250 newtons. Meaning static friction can be anywhere between 0 and 250. It need not be 250, but it cannot be more than 250. That's what the static friction says. Then how do you find static friction? There is an indirect method of finding static friction. That indirect method is using Newton's laws. From Newton's laws of motion, you can find static friction. Static friction should cause acceleration. Okay. Static friction should cause acceleration. And that is why it should be equal to mass into acceleration. Mass is given as 50 kg and acceleration is 2 meters per second square. Okay. So we got 100 Newton. 100 Newton is the answer. 100 Newton. So whenever they ask you to find the static friction, when they ask you, first find the nature of the friction. Then once you know it is static friction, you can't use Fs equal to mu s into n. Fs has to be less than or equal to mu s into n. All right. And kinetic friction is okay. That's an easier one. Static friction is very silent killer, you say. It's dangerous, static friction. It does not produce any sound. It does not produce any vibrations. It does not produce any heat. It's very silent. Okay. Kinetic friction is very, very noisy. Kinetic friction is like a Rajnikant. So when kinetic friction enters onto the screen, it's a lot of hangama. So when Rajnikant comes to the screen, right, especially entry level or any South Indian heroes, when they enter onto the screen, first entry, lot of hangama will be there, vibrations, entire theater will get vibrations, sound, right, sparks will come and all that. Kinetic friction is something like that. Whereas static friction is a silent killer, you don't even know that he's present there. No vibrations, no sound, no heat produced. You just have to find him using indirect method, that is Newton's laws. Kinetic friction is very easy to find, very easy to detect also. All right. So whenever they want to give easy question, they give on kinetic friction. Whenever they want to give a tougher question, they give static friction, because static friction is not easy to calculate. You got to go with the indirect method. Okay. All right. One more question on this, on the same idea. One more question. Now we got friction. All right. Third part of the question. So mass of the person is 50 kg. Okay, we got it. We had given already. Acceleration was given as 2 meters per second square. Acceleration equal to 2 meters per second square. And friction also we got static friction, which is 100 Newton, not 250 Newtons. Some of the participants had given the answer very nicely. Okay. It is static friction. Now let us assume that he travels for a duration of, time duration of, the person is running, right? So assume that the person is traveling for a time duration of 5 seconds, for example. Okay. He travels for the time duration of 5 seconds. Initial velocity is given 0. Now the question is, determine work done by friction on the person during this interval. Determine work done by friction on the person during the interval. Determine work done by the friction on the person during this interval. So let me see. So after completing this question, I'll tell you my idea of this particular course, what is expected for advanced examination. Just I'm taking this question as an example. Then you will come to the description of the topic, what is expected from this program, all those things I'll explain it. A little problem with the handwriting for today because of the software shakiness, but anyway, so I hope you are able to follow this. Okay, so Mithilesh Kumar has given the answer. Syed Ibrahim has given the answer. Narati Bhaskar. Okay. Srinivasa Rao Bolineni. Okay. Then Hakim, he has given. Trivedi, Sesi Kumar. All right. So whenever you want to find the work done, all right. First of all, what is the definition of work done? Okay. Definition of work done. Work done is defined as force into displacement of point of contact, point of application. All right, displacement of point of application of force. Okay, force into displacement of point of application of force. So generally, students, they remember like the force into displacement, they'll write which displacement, that they will not give that much care. That's where the teacher and paper setter can fool them. Okay, see, the person who is running here, he is not a rigid body, he is not a one-piece body, and when he is running, different parts of the body are moving in different directions with different velocities. Hands move back and forth, all right, and legs fold, bend, and all that happens. The middle section will go straight. So there is upward motion, downward motion also. Little jump also happens there. So it's a composite body. It's not a rigid body. and it is not in translation. Person is not in pure translation. Pure translation in the sense every part of the body is going with the same velocity in the same direction. No, it doesn't happen like that. When you are running, different parts of the body will have different velocities. So which velocity should I take? Which displacement should I consider? Point of application. The friction is acting where? Friction is acting on the foot. Displacement of point of application, when they ask you, we need to talk about the displacement of foot of contact. Foot of contact. So foot of contact, not the foot on the air. Foot on the air is not experiencing any friction. Foot on the ground will be experiencing friction there. So this is the definition. But this foot on the ground is not continuously on the ground. Sometimes it is on the ground, it is jumping again, getting displaced. So point of application is not moving in a continuous manner. It's a complicated motion. Foot motion is complicated. When it is on the ground, it will be stationary because it is not skidding. When it is in air, it moves. Again, it places somewhere else. So whenever you have a complicated motion, right, it is difficult to find the displacement. In that case, we'll go with the integral f bar dot v bar formula. F bar dot v bar times dt. Power we can calculate. F bar dot v bar is power. V bar dot dt is work done. V bar into dt is work displacement, right? F bar dot v bar into dt we can write. What is v bar here? V bar is a velocity. Velocity of foot in contact. This is a velocity of foot of contact. So velocity of foot of contact is actually zero. Null vector. When it is in contact, it is not moving. Ground is stationary and it is not skidding on the ground. That means the relative velocity between the foot and the ground has to be zero. Upper part of the body is moving. Center of mass is having acceleration 2 meters per second square. Head will have different velocity. Hands will have different velocities. Center of mass will be somewhere here. That will have constant acceleration. All right. But the foot will have a zero velocity when it is in contact. While it is in contact, that's where it is going to be point of application. So force dot velocity is zero. That means it is a zero power. Integral 0 dt. Integral 0 dt, meaning work done will be zero. Right? Work done by friction here is zero. So some of the participants had given the correct answer. Work done by the friction is zero. Very good. So I see Mithilesh Kumar sir and Syed Ibrahim sir. Okay. And then we have yeah, so these are the people who had given the correct answer. Some people had gone for the other one. Okay. But anyway, so I hope you understand. Work done definition is not force into displacement. Don't write force into displacement, you will get confused. Right? Force into displacement of point of application. Whenever the point of application is complicated, then you go with the other method. Integral, the displacement is what? ds bar, let us say. Infinitesimal displacement is ds bar. Na? Ds bar you can write as v bar into dt. All right. This way, if you write, then solving this kind of questions where point of application is changing, complicated, moment to moment it is changing, such kind of questions you can handle it better. And so work done by friction is zero here. Okay, very good. Work done by friction is zero. All right. Then who is providing him kinetic energy? Who is providing him kinetic energy? His kinetic energy is increasing. His kinetic energy is increasing. He was having initially zero kinetic energy. At the end of t equal to 5 seconds, his velocity of center of mass would be what? 2 into 5, 10 meters per second. All right. So at the end of it, he will have a kinetic energy at 5 seconds. That will be equal to half mv square. All right. Half into mass is 50 into 100. So kinetic energy he is gaining. Where is that kinetic energy comes from? So kinetic energy half into m into v square, that will be 2500 joules. All right. This much kinetic energy he is gaining. Friction is not doing work. How about gravity? Gravity is vertical. Center of gravity is moving horizontally. Force is vertically. When the force is perpendicular to displacement, work done by force has to be 0. All right. Gravity is not doing work. Normal reaction is not doing work. Friction is not doing work. All the external forces are contributing 0 to work done. Then where is this kinetic energy coming from? Because we know from work energy theorem, all right, work energy theorem, work done by all the forces equal to change in kinetic energy. But forces are not doing work here. Normal reaction is not doing work. Friction is not doing work. Gravity is not doing work. Who is providing this kinetic energy then? Where is this energy coming from? Somebody has to work to get energy, no? Somebody has to do work to get the energy. So yes, rightly said, Suresh Reddy sir, and then Mithilesh Kumar sir, and then Srinivas Rao sir. So they had given correct explanation. Here work is done by internal muscular forces. Internal muscular forces. You are getting tired. You get exhausted. You are losing energy because your muscles are getting contracted, relaxed, contracted, relaxed. They are doing. There is a displacement of microscopic muscular fibers there. There is a tension. There is a forces are there that are involved. They are non-conservative forces, muscular forces. So muscular forces are performing work. Muscular forces are performing work. So they are producing energy there. But muscular force is internal force. So internal force is able to give kinetic energy, but it is not able to give acceleration. We know that acceleration is only due to external forces. Acceleration only due to external forces. Only due to external forces. So this guy is accelerating because of friction. All right. This person is accelerating because of friction, but he is increasing his kinetic energy because of internal forces. Kinetic energy can be increased by either F external or F internal or both. Any kind of force can change kinetic energy, but only external forces can change velocity of center of mass. So this is a very interesting question here. So velocity is changing because of friction, but kinetic energy is changing because of internal forces. So this is a very, very interesting question. Anyway, I'll stop here. What is the basic idea? What is the basic idea of this particular question? I'll go back to the first page again. See, the first question they had asked, it is about friction, right? First question is about friction. And then you got to use Newton's law here. Newton's law has to be applied. Friction we have to use. Then we went to magnitude of friction. Again, this is also friction chapter. Then we went to work done. That means it is a work energy theorem chapter. And so if you want to solve this particular question, right, you need to have a complete understanding of Newton's laws. All right. Also should have the understanding of work energy theorem, work for energy, what causes acceleration, what causes change in kinetic energy. So one particular question, if you want to solve at advanced level, you might have to have lot of concepts clarity, and also attacking the question in an objective manner. Directly don't attack. You give a reasoning to get the answer. Based on the reasoning, if you go, you'll be able to get it. So I see that many a times the questions that we get in advanced examination, each option, if you look at it, is like mains level only. In a question, each option is like mains level question only. But in 4 options, probably 2 or 3 mains level questions are involved. Then it becomes advanced question. Nowadays, even mains level also, they are giving good questions. So if you want to solve one particular question completely, you need to have a complete understanding and also ability to mix the concepts, right? Concepts of various chapters, you should be able to mix and get to the answer there. That's what I have been observing in this IIT advanced papers over the last 4-5 years. Earlier pattern was different, but recently, if you give a question, right, this question involves multi concepts, multi-chapter ideas also sometimes. and complete clarity, right? Clarity is very, very important. As such, this particular question is not tough. It is not a difficult question, but it is a conceptual question, right? The question is really conceptual, definitely, but I don't see that it is a difficult question. Some of the students, some of the faculty members who had the conceptual clarity, they're able to do it. But idea is that whenever you want to go for advanced examination, please don't run behind the tough questions. Please don't run behind the difficult questions. Run behind the conceptual, tricky questions where you require little thinking, not just based on the formula. So that I think will be better off. Okay, so having said that, I'll just give you a brief idea. If any doubts are there, if you have any doubts, please raise your hand. I'll unmute you. You can ask questions. Those who have any doubts, any questions you have, anything you want to ask. So this particular program is very good in the sense, it's a nice initiative, definitely. So there is Balaraju. I'd like to, okay, I'm trying to unmute you. Do we have admin there, please? Can you please unmute Mr. Balaraju? Yeah, Balaraju, sir.
Sir. Yes, sir.
Your voice is not audible. Balaraju, sir, you can speak now.
Yes, sir. I am speaking now. Hello, sir. Hello.
No, I'm not able to hear you. Ram, sir. So I think there is some mic problem at the other end. All right, then. You can chat me if there's anything to discuss, right? Because I'm not able to hear your voice. Okay, right. Let's take one more question. Yeah, this is a nice question. Check it up. This is a very good question. Let's discuss about it. There is a tiny sphere. Okay, this is a conducting sphere. All right, carrying a charge Q. And then we have another sphere here, over here, carrying a charge minus Q. Both are conducting spheres and they are separated. All right, they are separated in a medium. They are kept in a medium and they are separated by a distance 2d. So next time what I'll do is I'll bring the questions in a printed form so that time can be saved while writing it, and also this handwriting is this particular software. I think this is better, this software. So yeah, so over here you have the origin. Let's assume that this is positive x-axis and this is negative x-axis. All right, now you have, probably you can take this as y-axis and this is z-axis. So we are considering three-dimensional space here. Okay. Now both the objects are kept in a weakly conducting medium. weakly conducting medium. So medium is generally insulated, right? But this particular medium is weakly conducting. It can supply charge. So in the sense now charge is leaking. There is a leakage of charge from positive charge to negative charge in the medium. It's a medium we are talking about, weakly conducting medium. All right. Let's say conductivity is sigma. Conductivity is given. Conductivity is sigma. All right. Now, if you actually look at the charges, right? Charges will move from one conductor to the other conductor. So actually electrons will move in opposite direction, but will show conventional current direction. It goes in this like this. Current is flowing. We call it as eddy current. Eddy current meaning current which is flowing in a medium, right? It doesn't have a defined path. It can take its own path in the medium because medium has infinite space. Now like this, the current is flowing, right? So current is flowing in the medium, three-dimensional you have it. All right. I'm just showing certain lines only to indicate the direction part there. All right. Now the question is what we will do on the y-axis. On the y-axis, I'll take a point. Let's say somewhere here, I'll take a point over here, point P at a distance some y. We need to find magnetic field at P. Magnetic field induction at P due to the currents that are flowing in the medium. There are eddy currents flowing in the medium, right? Because of the currents which are flowing due to the potential difference that is created due to charges that are present. So we need to find a magnetic field at P. It's a weakly conducting medium of conductivity sigma. We have to find the magnetic field at P. The point P is located on the y-axis at a distance y. So this is a very nice question. We can divide this question into various parts. Yeah, Ram sir, do you have anything to ask? See, this particular question came in Olympiad exam. So what is the basic idea? Now you have two charges. The charges will produce a potential difference. They create electric field. In the medium, there is electric field. So that electric field will drive current, but eddy current, meaning it's not going in a defined path, going in all directions in the entire space. Okay, but charges will flow from positive charge to negative charge, like so. It's like a capacitor, let us say, but spherical shells. Plates are spherical shell. Charge is flowing through the medium because the medium is leaking. It's a leaking medium. Usually we take insulating, but here we are taking leaking medium. The current is flowing there in medium. Now, because of that, magnetic field will be created. So it's like basically it is going to cover 3 chapters. First, you need to cover electrostatics. We need to find electric field. No? First, you need to study electrostatics, and after that, you go to electric current. We need to find currents there, and current produces magnetic field. Current produces magnetic field. Okay. First, electric field you have to find. From electric field, you find current. From current, you find magnetic field. That's a basic idea. All right. But this particular question, there were some students from our batch only, I mean our students only. This was in the year 2013. One of our students, he went to International Olympiad on behalf of India, representing India. So what happened was he didn't solve it. He just wrote question cannot be solved. By some reasoning, he said question cannot be solved because of certain reason, and he got full marks for that. That was very interesting. Technically speaking, this particular question is wrong. But then you can excuse it because in physics, right, we always do a lot of approximations. We don't do it exactly. Lot of idealization models we take up because reality is too complex. Whenever you are studying reality, you don't go to the reality directly. You take ideal models, simplified ideal models, and then you solve them, keep on adding the complexity to get the reality. That's how we study physics. So here he said simply, see, whatever, when the current is flowing, right? When the current is flowing, charges are decreasing. When the charges are decreasing, electric field at any point, magnitude will be decreasing. When electric field is decreasing, currents will be decreasing. Currents are decreasing, meaning it is unsteady current. All right. It is varying with time, no? Unsteady current. So time varying current. But we have this magnetostatics chapter where we use Biot-Savart law. Biot-Savart, we should call it as, but the spelling is like Biot-Savart law. All right, you have studied about it a lot. We do a lot of questions on it. Biot-Savart law, then Ampere's law. All right, Biot-Savart law and Ampere's law both are very similar to Coulomb's law and Gauss law in electrostatics in terms of solving problems. Biot-Savart law and Ampere's law, they are valid only for steady currents. Only for steady currents. But here I have unsteady current. That is why this Ampere's law and Biot-Savart law cannot be applied. And so he said like this. So this question cannot be solved because I can't use Biot-Savart law, I can't use Ampere's law. And unsteady currents handling is graduation, post-graduation level, where we deal with relativistic phenomena, and then you have electromagnetic wave theory also should be used there. It becomes very complicated. But using Biot-Savart law and Ampere's law, technically you are not supposed to solve it because Biot-Savart law and Ampere's law are valid only for steady currents, whereas here I have unsteady current. That's why I cannot solve it, he said, and he got full marks for it. But having said that, anyway, physics guys, they gave one particular wording here. You see, the wording here is weakly conducting. It's a weakly conducting. It's not a very strongly conducting. So current is there, but it is a very small current, and the charge is decreasing, but it is decreasing very slowly. So if you take a very small time duration, maybe a few seconds duration, during that time charge is changing definitely, but the variation is negligible. You can take the charge to be almost constant. So that variation you can neglect it, neglecting the variations and applying Biot-Savart law and Ampere's law approximately we can solve it. That's how they had come to reconciliation. But anyway, this guy got full marks. Those who solved also got full marks. I hope you understand what I'm saying. If there are any doubts on that, please let me know. It is eddy current. Displacement current comes when you have unsteady currents. Okay, unsteady electric field. When you have that, that's where you will get a displacement current. When you are dealing with displacement currents, it becomes pretty complicated. You got to use del operators, divergence, curl, and all that. So that becomes out of IIT advanced syllabus. So there they have given very specifically weakly conducting, in the sense that you can take the current to be approximately steady. It's not exactly steady, but approximately steady. Under that assumption, we can solve it. That means we can use Biot-Savart law and Ampere's law here. If there is, if you are following, just put a thumbs up. Whatever I had mentioned so far, If you followed, if you are okay with it, put a thumbs up. I'll try to solve this question now. We'll try to solve it. You can also try it. So maybe you can take it as like homework. It's a very interesting question. Okay, so now we got the route map of how to solve this particular question. So what I'll do is first find electric field. We'll try to find the electric field. First part is finding the electric field. You have Q here, all right, and then you have minus Q here. So, and then the point is over here, point P. So if you look at the electric field, you do positive charge, it will be away from it. This is a direction. E bar due to positive charge, away from it. Due to negative charge, the field will be towards it. All right. So let's say this angle is theta. You imagine a line over here. This will also be theta. And by symmetry, this is also theta. And let's assume this is R. You drop a perpendicular. They gave this as Y. This is D. This is mathematical construction. And we know R equal to square root of Y square plus D square. All right. Now, electric field due to positive charge, electric field due to negative charge. Both of them will have same magnitude, and that is equal to KQ by R square. Point charge, no? I'm assuming steady charge. Actually, this formula is also not accurate. This formula is applicable only for static charges. Here, charges are moving, so it's not exactly valid, but we are neglecting those variation of charges here. Okay. Now you see resolving it. E plus component horizontally would be cos theta, vertically would be sin theta. Similarly, E minus component horizontally cos theta term and vertically sin theta term. You look at the vertical components, they are opposing each other. E plus vertical component is upward, E minus vertical component is downward. They cancel out. So if I calculate net electric field at P, all right, and that will be equal to 2 times of, because two fields are there, into KQ by R square is the field 1 magnitude into cos theta. Only cos theta component survives. And this is a field. That is the first step. We got the electric field. All right. Once I have electric field, next step is we have Ohm's law, current electricity chapter. You go to current electricity. There we have Ohm's law. Ohm's law gives the current, no? Ohm's law, there are two ways of writing Ohm's law. One is delta V equal to IR. That is in terms of potential difference. But same thing you can write as E bar equal to rho into J bar. E bar equal to rho into J bar. Both of them are Ohm's law only. One is Ohm's law for the wire. The other one is Ohm's law at a point. Ohm's law, there are two forms. The original form is the first one, delta V equal to IR. But delta V equal to integral E bar dot DL bar. And I equal to J into area. J is current density. Okay. And rho is resistivity. Rho is resistivity. J is current density. I'm assuming that you know it because it's a regular model question. Now that electric field is there, I can use that electric field to find current density. I'm just giving the format how to find current density equal to 1 by rho into E bar. All right, 1 by rho into E bar. You get current density from there. E bar, we got it. E bar is there in the equation 1. No? So I get current density. Once I have current density, then what I can do is, the third step would be, you imagine a circular loop. Imagine a circular loop in YZ plane. And this is YZ plane. So this is a circular plane, circular loop. In YZ plane. Okay. Radius is Y. Radius equal to Y. So now when the current is flowing through this loop also. No? The current is flowing through this loop also. I want to find the current through the loop. I'm finding the current through the loop. That is going to be the third step. I'm turning the page. I'm going to the next page. Current through the loop. So current through the loop, we have to calculate. I, as a function of Y, I want to calculate. So for that, if you look at that loop, all right, of radius equal to Y, no? And this is x-axis. X-axis is like this, right? And the current is flowing through it. That's what the current density is saying. Current density we got, right? So current is flowing through this entire cross section.
Hello.
All right. What we can do is we can do integration. We can use integration. What you do from here at a distance r, you take a circular loop of radius r and width dr. Okay. And through that the current is going. That part of the current I have to calculate. Di, let us call it as. So Di equal to current density into area. Current density, we got it in the previous equation. Area would be 2 pi r dr. So I hope you all know these kind of things. Finding the circular element and then finding the area. Now if I want to find I, I'll just integrate it. Integral j into 2 pi r dr. R running from 0 to y. Up to y radius, we have to find what is the current flowing through that. J is a variable here. You can see J is a function of y. Because the electric field is a function of y. R is a function of y, so electric field will be a function of y. When you substitute electric field here, J you will get as a function of y. All right. So current density, I got it. From current density, I can find current. That is going to be the third step. Then I go to fourth step, that is I use Ampere's law here. Ampere's law. Closed integral of b bar dot dl bar or b bar dot ds bar, whatever it is, equals to mu naught into I enclosed. By symmetry, you see that the current field will be circular loops here. There is a symmetry of the current. Current is entering here and then going like this. There's a symmetry. So based on that, you see that field has to be perpendicular to plane of current. Na? Current is in XY plane. So the field will be along Z axis, forming closed loops. So closed integral of b bar dot dl bar becomes b into circumference 2 pi y. And that is equal to mu naught into I enclosed. I enclosed. This is not current. I enclosed. Okay. So that is the fourth equation. And this I you substitute here, you get B. And how do you get I? You get from J. You integrate J, you get I, you get it. So there are 4 stages to this question. It's a very good question because it involves 3-4 concepts. You have to use electrostatics first. First one is you need to use electrostatics. First use electrostatics concept to find electric field. Then you go to current electricity chapter to find current density using Ohm's law, J equal to 1 by rho into E. 1 by rho equal to sigma. 1 by resistivity is conductivity. No? Inverse of resistivity is conductivity. All right. Then we go to the next part. Once you have current density, you can integrate to find current. Once I have current, then I can go to Ampere's law to find magnetic field. So that's a framework of solving the problem. All right. Why I have taken this question is, in advanced examination, when they give one question, they are giving multiple concepts, interlinking concepts. They're not giving one particular topic specifically on one particular topic most of the times. Very rarely we are seeing questions on a single concept in advanced exam. One question only will involve 3-4 concepts, like 3-4 chapters you might be involving it. That's what the paper setters are very much interested in. So compared to mains and advanced, if you look at, the difference is that in mains exam, if they give a question, it will be on a single idea, single chapter, single concept. But in advanced examination, you should be prepared to use multi-chapter concepts in one particular question to solve it. And another point, as I told you, learning concept, okay, you can learn by reading it, but mastering the concepts will come by solving problems. If you want to master the concepts, you need to solve some really good questions. Ideally speaking, or realistically speaking, any teacher will get their concepts through students only. Depending on the quality of the questions asked by the students, we develop. So myself, I have done my BTech from IIT Madras and MBA from IIM Bangalore. I've also worked in some corporate world in Bharat Petroleum and also one company, Covances. In 2004, I left all that and joined this education sector. So I worked in the Sri Chaitanya and Narayana, those kind of institutes you must be aware of. All right. There I worked from 2004 to 2016. Up to 16, I worked there in various capacities. I started my career as an associate lecturer. And then after 1 year, I was given classes in 2004. 2005, I got the classes. And then 2005, I taught long-term students where we got below 100, 3 ranks for the first time for Sri Chaitanya history only in one particular campus in Vijayawada. So I was really fortunate to get interacted with so many top students, extraordinary students. In 2011, there is All India first ranker Funny. He was my student. 2012, there is Sai Sandeep Reddy. He was also my student, All India first ranker. The same year, we got All India second rank. That was Mr. Ravichandra. He was also my student. The following years, we did not get first rank, but we got All India's 4th rank, 6th rank, 10th rank. Up to 2016, you might have heard about China campus, Chaitanya Narayana combined program, in which I was academic coordinator and also physics HOD. So after completing my work there in 2016, I moved out and I'm running my own institute now in Hyderabad. So VITG Doctors Academy, VITG and Doctors Academy. So we are running coaching center there. And Kiran sir, he approached me about this particular program, faculty training program. I was really interested about that. See, because now basically there are lot of opportunities in education sector, especially this online when it came in. So, the point is that proper guidance for the upcoming faculty who want to learn, because I was fortunate to get a good mentoring from my immediate boss. So his name was also SVK sir. He was there in Vijayawada mentoring me in the first initial stages. Thanks to him, there was another faculty, Mr. Deepak Pant. He's also working in Hyderabad. These two people really helped me in the initial stages to learn things much deeper way. They gave me that confidence that I can do anything. Whatever doubts I have, I was there. They have access. I have access with them, and I could talk to them, get explanation and all that. Very friendly, very affectionate. So that kind of guidance, if can be given to the faculty who are upcoming, enthusiastic. Now that opportunities are pretty more. All right. Not only India, it is not just defined limited to India. Even to the abroad, it is going on now. So if we can be part of it, I thought it will be a very good idea. That's why I agreed with this project in spite of my busy schedule. I'm actually running a full institute now because if you know, running institute about 500, 600 students, right? A lot of administrative things are there. And I'm also taking classes here as well, about 6 hours a day. So apart from that, this would be a really hectic one, but I thought it will be a good contribution if at all it is possible from my side. That's why I agree with it. And I'm sure it would be a good learning. So it's not that I teach and you explain something like that. It will be more like interaction part. But my objective here in this particular session is whenever you are attending this particular session, it is understood that you have basics. Basic understanding is already there. Up to mains level, you are comfortable. A basic level, you are expected to know already. Otherwise, there is another session which is focused only on mains. And apart from that, you want to learn little more extra, better techniques or better ways of solving questions and much more, little more clarity and all. That's expected here. So here, my idea would be to focus on advanced level, only advanced level focusing. So it is just an introduction part, kind of a session today. So there were little glitches in the initial stages, like that handwriting was a big problem, but I think now this is slightly better. Next time when we approach, we'll have a PPT ready so that this handwriting issue can be taken out. But I really love to listen to you also. What are your expectations? So all that. Yeah. So details of the course people are asking. So it will be 8-month duration. That's the idea. 8 months duration. Weekly 4 days you will have the classes. So probably around the same time you will have the class, about 1.5 hour duration every day, 4 days a week. And per day 1.5 hour. 1.5 hour class will be there. After that, you will be given assistance in clearing doubts and all. There will be a separate set of faculty where they will be interacting with you in clearing doubts, discussions and all. There will be discussion as well. That goes on. After that, Mr. Kiran would take up the responsibility of placing you in a good options. There are very good options available. Just that the faculty requirement is very much high. I know even in my institute also I require 2 faculty right now in physics and 1 faculty in chemistry. That requirement is very much there. All right. So requirement, you don't have to worry. A lot of requirements are there. You make sure that you are getting the maximum out of this particular course. So then definitely the sky is the limit. All right. You can actually almost like double your pay, whatever you're getting, if you got the sufficient knowledge and all that. So Mr. Kiran has got a lot of contacts. Thousands of people are in contact with him. So he knows almost every institute and all that. He will find out the requirements and then he will place you accordingly. So that particular thing, Mr. Kiran will explain to you in detail. So I'll be taking up physics along with me. My other fellow faculty members will join me. So mostly I'll be taking the chapters and all that. Additional support will be given by the other faculty. It is very nicely planned, very nicely planned. The total curriculum details and all that will be given to you by Sunday, this Sunday. The weekly, what are the topics we'll cover for each chapter, how many topics we take and all that. But here primarily it is going to be advanced, right? So what I'll do is I'll be following primarily this particular book. Pathfinder. I'll try to solve questions from Pathfinder. I'll take most of the questions from Pathfinder. So what I thought was, if you know a book which is common to both of us, it will be easy to interact. If you have some doubts in Pathfinder, you can ask me. All right. And I also, so reading for you also would be there. This is the book I'll be following for solving problems. Okay. But concept, you can't get one particular book. All right. Concept, whatever concept is required, I'll explain to you and we can have a discussion. That's all right. But for solving problem, you can take this book, Pathfinder. I think that's a very good book for physics. All right, almost like it's about 7:22. So I hope you got the idea, basic idea. You learn here. Learning is very, very essential. Every day we learn. As teachers, we learn every day. Compared to last year, this year I'm slightly better because of the interaction with the students. Everybody will have to learn. There is no superstars here. So whatever we are learning here, it is already written by some great scientists like Newton and all. We are not doing anything new, all right? Just explaining what is already there in the books. But how effectively we are able to explain, how interestingly we are able to imbibe into the minds of the student, that is also very important aspect. So that part we'll take care of. I think Mr. Kiran is also working on the other aspects, soft skills of a teacher. A teacher's soft skills, psychology, child psychology, you need to know a little bit. Communication skills and also are important. Such things are also being taken care of. This entire program is very exhaustive. If you are able to follow this throughout, definitely you will get a lot of benefit. Of course, you will get connections. PR is there anyway. Networking happens. You will get connected to many people. That is one thing. And learning would always be there. And that's another aspect. So you make use of this opportunity. All right. Definitely it is going to help you out. So that I'll conclude. If you have any questions, please type there. Otherwise, I'll conclude in a couple of minutes. Yeah, so somebody is asking about basic level course details. That will be shared to you. That will also be given. Yeah, fee details and all that will be given to you by Mr. Kiran. You please contact Mr. Kiran. Some of the faculty are there who are working in schools. So I suggest you to attend this mains program. All right. There will be a separate program, mains. Newton's laws of motion and rotational motion concept books referred. Yeah, in the due course, I'll explain to you. I'll give you. So there are a lot of books. See, you read a book, you will learn, but you won't get mastery. You have to solve problems. Okay. Anyway, I'll give both. So I primarily follow Professor H.C. Verma concepts of physics in general. Resnick and Halliday is also there. There is one book, Feynman Lectures. It's a very interesting book for the physics lecturers, but it is very exhaustive, much beyond graduation level also. Feynman Lectures is one book. And then there are more like Irido book is there. Some Russian books are there, all that are present. So instead of following so many books, whatever is given here, if you follow, I think that will be helpful for you because everything will be culminated and given to you in one particular way. Basic is different and advanced is different. Basic will be taken care of as a separate program, and this particular program would be advanced level. All right. So timing would be the same. I think 6 o'clock would be convenient. All right. I hope it is convenient for all of you. 6 to 7:30 probably. If that is okay, I will continue. Otherwise, if you want to take it little about maybe 5:30 to 7. All right. So I think Mr. Kiran is mentioning it. So 5 o'clock. Yeah, that depends on your convenience. I'm okay. From 5 o'clock to 7:30 during this time, I'm okay. I'm available. So Mr. Kiran will decide the timing and all. Yeah, school teachers will have this basic course. That will be a separate one. Yes, correct. So you please contact Mr. Kiran for the other details. All right. I hope you have his number. Otherwise, I'll just write it here, Mr. Kiran. Kiran sir, you can, yeah, Kiran sir has sent a message to you, contact number. Maybe you can meet him. Okay, then. So in that case, we'll close here. So very nice interacting with you. I hope it was useful for you. As we go on, it will be much more systematic. All right. Okay, then. See you. Bye. I'm closing here.